Hi, I'm McNeely, and I'll be doing problem 56 from chapter 20. The problem reads, two identical resistors are connected in parallel across a 25-volt battery, which supplies them with a total power of 9.6 watts. While the battery is still connected, one of the resistors is heated so that its resistance doubles. The resistance of the other resistor remains unchanged. Find A, the initial resistance of each resistor, and B, the total power delivered to the resistors after one resistor has been heated. So we have our knowns, which is it's two equal parallel resistors with a 25-volt battery and a total of 9.6 watts of power. So we're able to draw what our circuit may look like. From this, we're trying to find what R1 and R2 equal. We know that R1 equals R2. So we choose this power formula, which we have two knowns already, the power and the voltage, and we can use that to find the equivalent total resistance. So the total equivalent resistance equals 25 volts squared divided by the 9.6 watts, which we get a total equivalent resistance of 65.10 ohms. From this, we'll then plug that into the resistance equivalent equation for parallel resistors. 1 over R equivalent equals 1 over R1 plus 1 over R2, which, since the resistors are the same, winds up being 1 over R plus 1 over R, which simplifies again to 1 over the resistance equivalent equals 2 over R. From there, we'll plug in our total resistance of 65.10 ohms. 1 over that equals 2 over R. We can then cross multiply to get R equals 2 times 65.10 ohms. And we multiply that out to get R equals 130.2 ohms. So our answer for part A is the initial resistance of each resistor is 130.2 ohms. Move on to part B. We should have the same circuit set up. We know that the volts is 25 volts. R1, one resistor, stays at the 130.2 ohms that we found in part A. And another resistor, which is heated, doubles. So we multiply that out to get the second resistor is 260.4 ohms. And we're looking for the power. We can use the same power equation of the volts squared divided by the total resistance. So we'll use 1 over the total resistance equals 1 over R1, which was 130.2 ohms. And the second resistor, which was heated, 1 over 260.4 ohms. So 1 over the total resistance is equal to 5 divided by 434. We take the inverse of each side, we get the total resistance equals 434 divided by 5. So our total equivalent resistance now is 86.8 ohms. We then plug that into our power equation of power equals 25 volts squared divided by 86.8 ohms. And we get our total power is now 7.2 watts. So our answer for part B is the total power delivered to the resistors after one of the resistors has been heated is 7.2 watts. Thank you.